Hello everyone, welcome. This is the 8th chapter, Advanced RMI. So in this chapter we will look at some RMI's interesting advanced features, namely stub downloading, security manager and client callback. Okay. So in this chapter we are going to study stub downloading, security manager and client callback. So client callback, consider an RMI application where participating processes must be notified by an object server where a certain event occurs. Example, participants in a chat room need to be notified when a new participant has entered the chat room. One way to accomplish the transmission of such information is for each client process to poll the object server by repeatedly invoking a remote method. The polling. So what is this polling? Polling is a technique employed in many network programs, but it is a very costly technique in terms of each systems of resources, as each remote method invocation takes up a separate thread on the server host along with the system resources that its execution entails. A more efficient technique is known as callback. It allows each object client interested in the occurrence of an event to register itself with the object server so that server may initiate a remote method invocation to the object client when the awaited event occurs. So polling is a technique, it's a very costly technique. So what is that? We will see that. So here polling and callback. See, in this first one, this is polling. A client issues a request to the server repeatedly until the desired response is obtained. So some desired action is taken place or event is occurred in the server. So when that event is occurred, for that event, the notification, the client will repeatedly send a method call. Okay, client issues a request to server repeatedly until it gets the desired response. So this client is looking for some event, whether that event is occurred at server side. For that, it repeatedly issues the call to server. Okay, so this is the polling. So next one is the callback. So here in callback, there is a client and server. A client registers itself with the server and waits until the server calls back. So here in callback, the client registers itself with the server for the certain event. So when that event occurs, the server makes calls back, or server calls back the client. Okay, when that event occurs, the server will make a call to client. Okay, but here in the case of polling, so polling is a costly technique. For this method invocations, it uses the separate thread. Okay, so here the client will repeatedly send its request to the server, whether that to check whether the event is occurred. But here the client will register itself with the server, and when that event is occurred at server side, the server will make a call to client. This is callback. Okay, and here in RMI, client callback is a feature that allows an object client to register itself with the remote object server for callback, so that the server may issue a remote method invocation to the client when an awaited event occurs. So in this callback, the client has to register itself with the remote object server, but when the awaited event is occurred, the server calls back the client. So here the client callbacks, with the client callbacks, the remote method invocations are now so here two-way or duplex from the client to the server and server to client. Okay, so the remote method invocation is in two-way. So here it is two-way because see here two-way, that is client to server and server to client. So the client, here the client, and it sends request to, it makes a method call to server, and here it server makes a method call to client. So here server will become client and client will become server here. Okay, so when the server calls back the client. So the client callback, when an object server makes a callback, the roles of two processes are reversed. The object server becomes a client of the object client so that the object server may initiate a remote method invocation to the object client. So here in the client callback, the server becomes the client and the client becomes the server. So there is a figure, it illustrates the architecture of RMI with the client callback. Compared with the architecture for basic RMI, two sets of proxies are required. Already you have seen in the previous chapter, that is our basic RMI, the two sets of proxies are required. One set is required for the server remote interface as in the basic RMI architecture. The other set of proxies is for an additional interface, the client remote interface. The client remote interface provides a remote method that can be invoked by the server for the callback. See, this is the architecture of RMI with the client callback. So RMI architecture of RMI with client callback is called advanced RMI. Okay, in the previous chapter we have seen the basic RMI architecture, but the advanced RMI or RMI with client callback is this. So here also there is object client and directory service is there, object server is there. So the object client makes a call to remote method call to object server. For that it will look up to the directory service for the reference. Okay, so it will get the reference. Using that reference it will make a method call, the client will make a method call. Okay, so here see this is this dashed line, the dotted line is client looks up the remote object. Solid line is for client invokes the server's remote method, and this dashed line server invokes the client's callback method. Okay, the same as basic RMI, but see the difference here. Object client, the call is transferred to the stub server interface stub layer, and next it is transferred to remote reference layer and to transport layer. So here also the TCP IP, this is based on TCP IP. So the call is made to the server and it will go through this transport layer, remote reference layer and server interface layer or skeleton to the object server. But here the one difference with the advanced RMI or callback, so it will make a callback. So here the client becomes, the server becomes the client here. So when the callback, it makes a callback. So this dashed line represents the callback. So it will go through the client stub layer. So at the both, at the both sides we need stub and skeleton. So here skeleton is there at server side and also at the client side, because the client becomes server at the callback time. At the time of callback the client becomes the server here. Okay, so the object server makes a callback. So this is the callback is made through client stub layer and it will go through remote reference layer and transport layer, and here to transport layer and remote reference layer. So here our client became the server here, so it will go through skeleton and it will make a method call to object client. So this is the difference between basic RMI and callback RMI with the client callback, that is advanced RMI. So now the algorithm for developing the server side software. See, server side software of the RMI with the client callback. See, first of all, open a directory for all the files to be generated for this application. Second one, specify the remote server interface in callback server interface.java. Compile it until there is no more syntax error. Third one is implement the interface in callback server implement.java. Compile it until there is no more syntax error. Fourth one is use the RMI compiler RMIC to process the implementation class and generate the stub file and skeleton file for the remote object, that is RMI callback server implementation. The files generated can be found in the directory as callback server implementation skeleton.class and callback server implementation stub.class. Step 3 and 4 should be repeated each time a change is made to the interface implementation. Fifth one is obtain a copy of client remote interface class file, and alternatively obtain a copy of source file for the remote interface and compile it using javac to generate the interface class file callback client interface dot class. So the sixth one is create the object server program some server dot java, compile it until there is no more syntax error. Seventh one is obtain a copy of client remote interface stub file, callback client implementation stub class, activate the object server java some server. See the algorithm for developing server side software. First of all, open directory for all the files. Second one, specify the remote server's interface. Second one is specifying the interface. Third one is implementing the interface and compiling. And fourth one is using Java, using RMI compiler RMIC to process and the implementation class and generate the stub file and skeleton file. Okay, so fourth one is using RMIC to generate the stub file and skeleton file. Fifth one is obtaining the copy of client remote interface class file using compile it using javac. And sixth one is creating the object server program. Seventh one is obtaining the copy of client remote interface stub file. Okay, and eighth one is activating the object server. So now algorithm for developing client side software. First of all, open the directory for all the files to be generated for this application. Second one is specify the remote client interface in callback client interface.java, compile it until there is no more syntax error. Third one is implement the interface in callback client implementation.java, compile it until there is no more syntax error. Fourth one is use RMI compiler RMIC to process the implementation class and generate the stub file and skeleton file for the remote object. The files generated can be found in the directory, and steps 3 and 4 should be repeated each time a change is made to the interface implementation. Fifth one is obtain a copy of server remote interface class file. Alternatively, obtain a copy of source file for remote interface and compile it using javac to generate the interface class file. Sixth one is create the object client program callback client java, compile it until there is no more syntax error. Seventh one is obtain a copy of server remote interface stub file and activate the client. So here the steps are first of all open directory for all the files. Second one is specify the remote interface. Third one is implement the remote interface. Fourth one is using the using the RMI compiler RMIC to implement the stub and skeleton files, and these stub and skeleton files are found in a directory, and repeating the step 3 and 4. And fifth one is obtaining copy of server remote interface class file using javac, compile it using javac to generate interface class file. Sixth one is creating the object client program and compiling it. Seventh one is obtaining a copy of server remote interface stub file and activating the client. So next one is the stub downloading. The next concept is stub downloading. In the architecture of distributed object system, a proxy is required to interact with an object client's remote method call. In Java RMI, this proxy is the server remote interface, that is stub. The stub class thus generated will need not be present on the client host at runtime for a client object program to execute. Java RMI provides a mechanism that allows stubs to be made available to the client dynamically. Using dynamic stub downloading, a copy of stub class does not need to be present on the client host. Instead, it can be transmitted from web server to the client host when the client is activated on demand. See here, in this architecture, in Java RMI architecture, a proxy or a stub file should be there. Already we have seen the stub file should be there at the client host, on the client host. Okay, but here the stub class can be generated need not be present on client host at runtime for client object program to execute. Okay, so but for executing the Java RMI architecture, the Java RMI application, we need a stub file, but stub file on client host, but the client host Java RMI provides a mechanism that allows stubs to be available to the client dynamically. There is no need to be always there on client host. The stub file no need to be always there on client host. We can download it dynamically. Using dynamic stub downloading, a copy of stub class does not need to be present on the client host always. Okay, so the stub class need not to be present on the client host always. So whenever we require a stub, we can download it. So this is called using a technique called dynamic stub downloading. So it can be transmitted from web server to the client host when the client is activated on demand. Okay, but for executing the Java RMI applications, we need a proxy. Okay, but we need a proxy on client host, but it does not need, the stub class does not need to be there on client host always, but whenever it is required, we can download it from the web server. So the technique is called stub downloading. The stub downloading makes use of ability to dynamically download Java software from any uniform resource locator, that is URL, to a Java virtual machine JVM running in a separate process, usually on a different physical system. Using stub downloading, a stub class is filed by the object developer with the web server as a web document, which can then be downloaded using HTTP when an object client is executed. Okay, that means the stub can be downloaded dynamically whenever it is required. As before, a server exports an object by contacting the RMI registry and registering a remote reference to the object, specifying a symbolic name for the reference. If stub downloading is desired, the server must also inform the registry of URL where the stub class is filed. So while downloading, the URL must be provided. A client that wishes to invoke a remote method of an exported object contacts the RMI registry on the server host to retrieve the remote reference by name. Without stub downloading, a stub object must be placed on the client host manually and must be locatable by the Java virtual machine. If stub downloading is in use, then the stub class is obtained dynamically from an HTTP server so that it can interact with this object client and RMI runtime support. The downloaded stub class is not persistent, meaning that it will not be stored permanently on the client host but will instead be deallocated by the system when the client session is over. Okay, so we can download if we are not using a concept of stub downloading. We need the stub file should be there on a client host. Okay, that should be placed manually on the client host and that should be locatable by Java virtual machine. If you are not using stub downloading technique, the stub should be manually placed in the client host. But if stub downloading, if you are using the stub downloading, the stub class is dynamically downloaded from HTTP whenever it is required, but the downloaded stub class is not permanent on the client host and it is deleted or deallocated by the system when the client session is over. So what is the use of this stub downloading? That is, we can save some memory on client host. by downloading whenever it is required. So the figure shows, there is a figure, it shows the stub downloading. See, this is the figure, see the steps involved here. This is the object client host and object server host. So this is first one. This is client looks up the interface object in RMI registry on the server host. It looks up the interface object. And the second one is the RMI registry returns a remote reference to the interface object. So RMI registry, it returns a remote reference to the client. Third one is if the interface object stub is not on the client host, if it is so arranged by the server, the stub is downloaded from HTTP server. So here the server using the HTTP, the third step is if the stub is not present on the client host, it is downloaded from the server using HTTP. Okay, the fourth one, via the server stub, the client process interacts with the skeleton of the interface object to access methods in the server host. So using the stub class, it makes a call to the remote object which resides on the server. Okay, so this is the stub downloading. So the next concept is RMI Security Manager. So what is this? Although stub downloading is helpful feature, its use introduces a concern for system security. Such a concern is not unique to RMI, but it is associated with object downloading in general. When an object such as an RMI stub is transferred from a remote host, its execution subjects the local host to potential malicious attacks. Since a downloaded object originates from a foreign source, the execution of its code is unrestricted, may potentially wreak havoc on the local host, resulting in damages similar to those caused by a computer virus. Okay, so if you are using the concept of stub downloading, so you are downloading a stub file from a remote host, isn't it? So there is a chance of virus attack when you are using this stub from a remote host or a foreign source. Your system is possibly it will get a virus attack. Okay, so to counter that problem, the threats opposed by the downloaded stub, Java provides RMI Security Manager class. An RMI program may instantiate an object of this class. Once instantiated, the object oversees all security sensitive actions that arise during the execution of the program. These actions include the accessing of local files and the making of network connections, since such actions may result in undesirable modification of local resources or misuse of network resources. In particular, the RMI runtime support requires that server process install a security manager before it can export any object that requires stub downloading, and that a client process install a security manager before it can download a stub. So to counter the threats posed by stub downloading, Java provides a Java Security Manager class. So the RMI program should instantiate the object of this class. The object oversees, so this object oversees all the security sensitive actions that arise during the execution of the program. Okay. So the Java RMI runtime support requires that server process install a security manager before it can export any object that requires stub downloading. So here the server should install a security manager before it export any object that requires stub downloading, and that a client process install a security manager before it can download a stub. So our client should download a security manager before it downloads a stub. So by default, an RMI security manager is very restrictive. It allows no file access and allows connections to the originating host only. This restriction, however, will prevent an RMI object client from contacting the RMI registry of the object server host and will also prevent it from downloading a stub. It is possible to relax these restrictions by installing a special kind of file known as security policy file, whose syntax specifies what type of restrictions a security manager, including RMI security manager, should enforce. By default, there is a system-wide security policy file installed in a special directory of each Java-enabled system. The restrictions specified in the system security policy file, the default restrictions previously mentioned, will be those enforced by the security manager unless you override it by specifying an alternate policy file. Alternatively, a security policy file can be specified for a specific application so that restrictions may be imposed on a per application basis. It is recommended that you specify a security file with each application that you run so that you may have control over the restrictions imposed on your applications only, that without affecting the restrictions imposed on others. See, this RMI security manager. So before downloading the stub, the client host needs to download the RMI security manager. But this RMI security manager is very restrictive. So it is so restrictive that it will not allow the client host to contact the RMI registry, or it will prevent it from downloading the stub also, because it allows connections to the originating host only. So it will not, the RMI security manager is very restrictive so that it will not allow the connections to any other host. Okay, so it will allow the connection only to the originating host, not to any other host. So here it will prevent it from, so this very restrictive method is it will prevent the client from downloading a stub. To avoid that, there is a special file known as security policy file. So it will specify what type of restrictions a security manager, including RMI security manager, should enforce. So it will, security policy file will impose which security restrictions are required. Okay, so you need to, the client host needs to download a security policy file to specify the required specific restrictions on specific applications only, so without affecting the restrictions imposed on others. Okay, so this is the RMI security manager. Why this RMI security manager is there means, during the stub downloading, you are contacting the foreign source. The stub is downloaded from the remote host, that is your client is contacting the foreign source. So there is a chance of malicious attacks, that is virus attack. To prevent that, there is a security manager class, RMI security manager class. So the client needs to download the RMI security manager. But this RMI security manager is very restrictive, that it is so restrictive that it will not allow your client to access any remote host. Okay, so that it is unable to download the stub file from remote host. To avoid that problem, we need to download a special file called security policy file. So this security policy file will impose only such restrictions which are required. Okay, which on the security policy file can be specified for specific applications only, without affecting restrictions imposed on others, or without affecting any other applications.